lines right here?
Yep. And they take the heat out to the buildings. These are air tubes that shoot, I think it's 3 tubes at a time, three heat transfer tubes at a time. So each one of these, every 500 seconds, it blows air through and cleans the heat transfer tubes. Mm-hmm. And that was what the circulator pump was for over here. It's all monitored by that little control panel. Tells you what the CO2 level is right coming out of the chimney. Monitors everything coming out through.
Will this run all summer?
Yes. Yep.
It'd be fun someday when it's off to take a look inside.
Absolutely, anytime. It's off a lot because it just heats this tank up. Once it's satisfied, this thing goes down.
When it's on in the summer, it's heating hot water for showers and stuff like
Correct.
that? Or,
yeah. Yep.
Is it an efficient way to provide hot water for showers?
We'll have that information soon. It's a lot cheaper than electricity. That's for sure.
How big is a big system to heat a few showers every now and then?
We're heating this. All we're heating is this.
But I mean, you got to take hot water from here and run all through those pipes, so those pipes have to be hot.
How big's the pipe?
Shower to get hot.
Inside all the insulation? How much of that's insulation?
I think it's 1.5 inch. Pipe. The amount of energy we're using to heat hot water is only slightly less than the amount of energy that takes to space heat the buildings for the entire year.
Really?
Yes. Oh,
wow,
it's only
incredible.
Slightly less. It's almost equal to the amount of energy it takes to heat the buildings.
Is part of that in the winter that when people use hot showers, they're actually heating the building too?
I'm sure it's negligible. We could figure out what it is. What we do have heat recovery systems on the waistlines, so we're gaining a lot of the heat back. We're hoping like 80% of the heat we're getting back. We've got cold water coming in. You're showering with hot water, and you know the physics of it goes around, and it doesn't go straight down the tube. It goes around and around and around and around and around. So we've got cold water going around and around and around against hot water going out, and so we're preheating that. We're stealing that heat coming back in. We have made it extremely difficult to switch over. You can see we do have backup propane. You can't just flip a switch in order to switch over from wood to propane. You've got to come down. There's a whole bunch of valves through here that some have to be closed, some have to be opened in order to do it. So it's difficult. So we're going to use wood. We're committed to wood pellets as much as possible. If we do go down, I'm embarrassed to say we can go to propane, but it's the only building on campus that we can. We don't have any backup for our oil.
Why do we choose to have a backup system here?
We had to. Well, we did. The board voted no. And then because we had to wait for this to get approval, we had to have something to heat them. And I have to say, there's been 2 times where we were lucky to have it. But we don't have it anywhere else, which is sort of the ultimate contradiction. We don't trust wood, but we do trust oil.
And the pellet, or this system is broken down more than the heating oil systems that are used in the other parts of campus, or have other parts of campus also lost power but didn't have backup?
It hasn't been down. We've lost a couple of relays. We've lost relays in other buildings. We didn't need that propane in order to do it. For convenience sake, we cut over. But we didn't have to. They're the most energy efficient buildings on campus. They're going to stay warmer longer than others. This boiler heats 37,000 square feet. All right? As of last year, it had never gone over 50% capacity. I think you already know the design load for those buildings is 10 BTUs per square foot at 10 below zero. So we put a lot of detail into making those buildings as tight as possible. So it's a system that works together. It's a great system. I love it. It's just like oil. But the bottom line is, not only are we using a renewable resource, but we're using it ecologically. We can be proud of the way we're using. Even if we were using oil or propane, we would be using it in a responsible way. And it has been, honestly, guys, a joy. It has not been. There's never a time we go, oh God damn the wood pellet boiler. A big change we've made this year is right behind you guys. The three-phase converter has been eliminated, and that's saving us about $9,000 a year in energy.
What is a three-phase converter?
This unit only recognizes three-phase power, and we only have single-phase power to the site. So we had to have it. We couldn't put it in if we didn't have three-phase. and we couldn't afford to bring three-phase to the entire project. I couldn't make it pay off to switch to three-phase power under our current contract, construction contract, because it would have been a change order. And we had to wait till the project was over. We tried it for a year, then I went back and I said, tell me what it's going to cost to switch over to three-phase power, only to as far as the boiler building. And it was paid for in the first year, $8,300, I think. $8,300 to get phase 3. So now that's not on. Anybody who was in here before will know, you came in here, you would be like, holy shit. But all the heat was coming from that converter. We really stayed on top of it as far as how it's working, and we still do all of the energy monitoring every month.